probability. We use it everywhere and every day. It's probably a branch of mathematics that you are a bit familiar with by now, but just in case, I'll give you an overview. All probability is the likelihood of something happening. So, let's say I have a fair coin. A fair coin has an equal chance of landing on either side, heads or tails. Now my question for you is, what is the probability that I will flip heads? The probability of flipping heads. Shorthand notation, we can write it like this. What is the probability of flipping heads? So what is that? Well, we know that there are only two possibilities of a flip, heads or tails. We also know that this is a fair coin, so each of these outcomes is equally likely to happen. Therefore, the probability of flipping heads is 1/2 or 1/2. Now here's an interesting question. What is the probability that I will flip 2 heads in a row? 2 heads in a row. So what is that? Here's one way of thinking about this. Let's draw a tree of outcomes to map our possible flip combinations. On the first flip, we can either have heads or tails, right? Okay, there we go. Now on the second flip, we can either flip heads or tails again, so we extend the branches of the tree. Heads or tails, heads or tails. Now we have 4 combinations here. Heads, 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 tails, tails, heads, and tails, tails. Oops, sorry, that's tails, tails. So, what is the probability that I will flip 2 heads in a row? 1/4. There it is, out of 4. We could even calculate the probability that I will flip 3 heads in a row, just by extending the branches of the tree. Okay, so we get 8 possible combinations, and only one of those is 3 heads in a row. Heads, heads, heads. Therefore, the probability that I will flip 3 heads in a row is 1/8. Hang on. There's a pattern here. 1/2, 1/4, and 1/8. We're just multiplying by 1/2 each time. So the probability that we get 4 heads in a row will be 1/16, and 1/32, and so on. In fact, we could calculate the probability that we will get n heads in a row by plugging a value into the equation. The probability that we will get n heads in a row is 1/2 to the n. Alright, that's pretty cool. A coin only has 2 sides though. Let's say we have a fair die with 6 sides. Now each level of our tree will split at 6 branches, and the probability that we roll, let's say, n sixes will be 1/6 to the n. Note how much less the probability is that you will roll double sixes than flip double heads. The probability that you will roll double sixes is 1/6 squared, 1/36, which is approximately 3%. The probability that you will roll 2 heads is 1/2 squared equals 1/4, or 25%. We can also apply this concept to real-world problems. I'm going to skip back up to the top of the page now, because here where I have room, let's say that there are 20 students in a class, 8 girls and 12 boys. The teacher puts all of their names into a hat and randomly draws a name, replaces it, and draws another name. She does this 4 times. What is the probability that the names are all girls? Well, we first figure out the probability that the teacher will draw 1 girl. The probability that the teacher will draw 1 girl. There are 20 kids in the class and 8 girls. There we go, 8/20. In other words, 2/5. So the probability that the teacher will draw n girls in a row is 2/5 to the n. We can substitute n equals 4 into this equation to get the probability that she will draw 4 girls equals 2/5 to the 4th, or 16/625. This is approximately 2.6%. For more problems like this, check the link in the description. Have fun!